Hey everyone, this is Vikas. Welcome to my YouTube channel. So today we'll talk about the regression matrix. Okay, basically there are multiple, but the three famous one is mean absolute error, mean square error, and root mean square deviations or root mean square error. Okay, here I have taken one example. There are 5 employees whose name are Vikas, Sachin, Prem, Himanshi and Ritu. So these are the employees who are going to join XYG corporations. We have given all the details about these employees, and we have built uh, we have taken some decision from the machine learning model, and machine learning model has predicted the salary for Vikas, Sachin, Prem, Himanshi and Ritu. These are the salaries. But once they got the offer letter, in the offer letter they got the actual salary of Vikas got 2,80,000, Sachin got 3 lakh, Prem got 1,20,000, and all the relevant values are here. Now, what is the predicted value from, or what is the predicted salary from machine learning model, and what is the actual salary got? So there is a difference, right? And this difference is nothing but that's a kind of error. So this is the error. If you'll see that here it shows 30,000 of difference, but for Sachin it shows minus 50,000 of difference. So this minus 50,000, that means the predicted salary was a little high, but actual salary was a little low. But this is the difference. Okay, so to take the mean, because here if we go for the error, so to understand the error for all 5 individual employees, what we have to do, we have to go for the summation of all this. But wherever we have a difference of minus, that would reduce the values. So in that case, if you consider this formula, which is the very first thing, is called mean absolute error. So mean absolute error, it shows summation of I is equal to 1 to n, means it has to consider from 1 to n, from Vikas to Sachin. So here we have total 5 employees, so we can say here n is equal to 1 to 5. So it will consider 1 to 5, where yi is nothing but the predicted values. This is nothing but the predicted values. Okay, and xi is nothing but the true value. So the difference of these two, and they have taken the modulus sign. Modulus sign means whatever minus value would be there, it becomes as a plus, so that we can consider the actual difference between the predicted salary and the actual salary, and we will divide with respect to the n. So here it will n becomes as a 5. So that would consider the average value. Okay, and that average value would be considered as a mean absolute error. I hope you understand that. Now if we'll go for the mean square error, so it is just same. Okay, it is just same. We have to consider, I mean, if we have to penalize the model more, so we have taken the square. Okay, whatever difference would come, let's say if this is 30,000, so make it square. Okay, this is minus 50,000, make it as a square. So see here we have used the modulus sign, both the side, right? Modulus sign, so that negative value becomes as a positive values. But in square we have not used, because if you multiply the square values, because here it shows yi minus yi cap, and there is no don't confuse with yi or xi. I have also mentioned in the below, because I have just copied this formula from the internet, so that it looks good for you, because designing in Excel sheet sometimes it will becomes here and there. All right, so here if you'll see that the difference between yi minus yi cap, where yi cap is equal to predicted and yi is equal to actual, so either you can take the difference between these two, from predicted minus actual salary or actual salary minus predicted salary, and then take the difference and make it as a square, and sum all the values and divide by n. So this average value would be considered as a mean square error. As the name also suggested, mean square error, we are taking the mean of all the errors, all the square of errors. Okay, and the third one is root mean square error. So few statistician, data scientist and machine learning engineer thought that we should penalize model less, because if you calculate the mean of this and divide by 5 by finding the mean absolute error, and if we'll go for the mean square error, so in that case there is a huge difference, because one is a simple absolute difference, another one is square difference, right? A difference of a square. So that becomes a huge values. So to make it you know nearer to mean absolute error, what they can do, you can take the difference, you can calculate the mean square error and just find the another root value. So root mean square deviation or root mean square error. If you see that here it shows under root summation of I is equal to n, okay, and the xi is nothing but your actual values minus xi cap is nothing but it's your predicted values, okay. Take the square, so this square is there, and again still we are finding the under root values. So this way you can find, I would suggest this way you can find mean absolute error, mean square error, and root mean square error or root mean square deviation, okay. So this three would be used, and the important question is like how to find where to find this absolute or a square or a root mean square error or root mean square deviation. It is being used interchangeably. So based on that, business requirement, if your business requirement suggests that you have to find the root mean square error, you can go for the root mean square error. If we just requirement says that you have to go for the mean square error in the regression problem, you can go for the mean square error. And if business suggests you to just go for finding the mean absolute error, go for the mean absolute error. And don't get confused about this convention. Somewhere I have used yi somewhere yi cap xi cap or xi. So just think about the predicted salary and the actual salary. So the difference between predicted salary and actual salary, and take the summation of that and find the average value, that is nothing but the mean absolute error. If you find the difference, make it a square of all those values, and then find the average value, that is called mean square error. And thereafter again, if you have to find the root mean square error or root mean square deviation, take the under root value, that would give you the root mean square error or root mean square deviation. I hope you like this video. If you really want to support us, please click on the like button, do subscribe our channel. And if you wanted to grow in your professional career by learning artificial intelligence, machine learning, deep learning, generative AI, so please do book a call with me, which is one-on-one call, and I would definitely love to help you in that. Thank you so much. We'll meet on the next video.